Today we learn about backpropagation in machine learning. Backpropagation is a gradient estimation method used to train neural network model. Gradient estimation is used in optimization algorithm to compute the network parameter updates. In it is the efficient application of chain rule to neural network. It is also as a reverse mode of automation differentiation reverse assumption due to shape polynomials. This term back progression error correction with introduced suggested by Frank Rose and Belt, but he did not know how to implement this even though J. Kelly had a continuous versions of back propagation already on this art in context of control theory. Backpropagation computing the gradient of losing function with respect to weight of network for a single input output example does so efficient computing gradient one layer at it track iteration backward from last year to avoid retention calculation of the intermediate term. In general, this is the through dynamic programming gradient descents or variant such as strict gradient descents are commonly used. Strict the term backpropagation refer only to the algorithm for computing gradient. Not how to gradient is used, but a term is often used. So, using to refer the entire learning algorithm include how gradient is used, such as a single descent such as David E. Harriman is published an experiment analysis on technique. This contribution of price of back propagation helped to initial to act period of research in multi-layer propagation over back propagation computation gradient weight space of as a neural network with respect to loss function that denoted x input vector of feature y target output for the classification output will be the vector of the class of probability 0.1 0.2 0.3 target output is basic class encoded by the one hot and dummy variable example 1.01 loss function cost function for classification. This is usual cross entropy xy and log x, which is regression is usually is square error slows SEL L number of layers W weight between layer 1 to L where the weight between the kth node in layer 1 to L jth node in layer F1 activation per net layer is the for class in last there is usually logistic function for binary classification in softmax and soft the argument makes for multi-class classification will the hidden layer. This is was traditional sigmoid function, logistic function, or other on each node coordinate, but today is more brilliant with redefined and ramp RELU being commonly activation of a jth node in layer 1 in a layer of backpropagation. Other intermediate quantity are used in introducing the match needed being based are not treated special since they correspond to weight with the fixed input of one for backpropagation. The special loss function and activation function do not matter as long as the derivatives can be evaluated. Official traditional activation function includes sigmoid traits, which mass or other activation function have since been proposed as well. Overall network is a combined function of one composition matrix multiplication GXL UW and for training set there is b set of input output pair x and y and for each output pair x y y the training set loss of the model on this pair is the close stop the difference between prediction output GXI and target output YI. CGI GX note the distribution during the model evaluation. The model are fixed while the input vary and the high output may be unknown and narrower and with the outer layer it cannot include loss function during model training. The input output pair is fixed with the weight vary and not work and with the Some backpropagation computes the gradient for a fixed input-output pair xi xy where the weight works can vary. Each individual component of gradient can be computed by the chain rule, but doing this separate for each weight is insufficient. Backpropagation efficient computing gradient by avoiding duplicate calculation, not computing unnecessary intermediate value by putting the gradient of each layer specific the gradient of weighted input of each layer denoted by from the net informal by Q of the since we only await in well affected loss and through it efficient on next layer it does not know linear. We are only data you need to compute the gradient of the weight at layer 1 then previous layer can be computed and replace recursive this avoiding insufficient in two ways. First is avoiding duplicate become when the computing gradient at a layer L it is unnecessary to recompute all drive on lateral layers L1 plus L1 to each time. Second, it avoid unnecessary intermediate calculation because it each stage is directly compute the gradient of the weight with respect to ultimate output of the loss rather than unnecessary computing a hidden layer with respect to change in weights and mission explained of simple forward network in terms of matrix multiplication of journal term of adjacent graphics matrix multiplication for a special case of feed forward network where node is each layer are connected only to node in the intermediate next layer without speaking any layer. This is loss function that compute a scalar loss of the infinite output function can be understood simply by matrix multiplication. Essentially, backpropagation simulates the expression of derivative of lost function as a product of a derivative between each layer from right to left backwards with the gradient of the weight between each layer being a simple modify of the percent product and backward propagation error given x and y loss. In the contribution they one start with us input x and work forward denote the weight input each hidden layer z output layer l as activation l before activation A is well driven fn eventually at must be catched by using during the back propagation the derivation of the loss in term of the input the given the chain rule node each term in total derivation even the value of network each node on the xeqa equivalent dynamic matrix in term of snowplow function derivative function of activation function and matrix of weight is that the gradient is transpose the derivation of the output in term of so matrix can transpose in the order of multiplication is revised but entire are same. The entries are same. So delta x v and back propagation then constant initial of evaluation this expression from the right to left actually multiplying the previous expression for the derivation for left to right gradient each layer on where there is adding step because the gradient of weight is not just the sub expression there an extra multiplication introduce the 20 potential on multiplying from right to left and treated as error at level 1 d infinite as the gradient of input value at level 1 noting vector of length equal to number of node in level 1 each component intermediate cost attribution to value of the to weight in layer and then factor a will become the weight level between the L1 and effect L1 property at input of activation this input fix the weight vary del can be easily to compute recursive going from right to left as gradient of weight can be thus be computed using few matrix multiplication for each level. This is backpropagation compared with native computing forward doing So there are two key difference with backpropagation computing in the term of statistical duplicate multiplication of layer beyond multiplier start from propagation error means each step multiplies a vector by matrix of weightage and row of sun by multiplication forward start from the change at yearly means each multiplication matrix by matrix. This is much more sequential track each possible path of changing one layer and forward to changing plus multiplication addition multiplication division of the equation much unnecessary computing internal quantity for how weight change affect the value of the hidden nodes adjacent graph more journal graphs other advanced way games progression can be understood automated and different. So when there is a special reverse automation and initiation some motivation in the goal of the supervised learning algorithm is finding a function that best map a set of the input to their correct output motivation of for vectorization is the train and multi-layer neural network that it can learn a particular internal any arbitrary mapping in output lineage optimization problem to understand metric and deviation of the backpropagation algorithm is well to develop some institution about the relationship between the actual output of the neurons and correct output for the particular training example considered a single neural network with the two input a unit one output unit and no hidden unit in which each neurons use a linear output unlike most work on neural network in which a mapping from input to output in non-linear that is weight sum of its input in the output layer initial before the training the weight will be set at random then neurons learn from the training example which is in this case constraint of set of actionality where x1 and x2 are input to the neuron city the correct output the output neuron should produce given those input which has been trained the neural network to give x1 x2 will be computed and output y that like different from the given random loss function and ty is used measuring the description between the target output a corresponding output y for regression is that a sequence error can be used as a loss function for classification categorical cross entropy can be used as an example consider regression problem using the square error as the description consider network on single training case one section thus input x1 x2 are respective correct output is 0 now it is relation upload between the neurons output y on horizontal axis the error e on the vertical axis result is parabola the minimum of the parabola to the output y which minimize the error e for in single training which is the minimum you also touch the horizontal axis which means the error will be 0 the network can produce output y that exactly match the target output therefore program of mapping input to output can be reduced up to function that can be produce the minimum error however of neurons depends on weight sum of the all its input y x1 x2 y2 where w and w are the weighted sum from input unit to output unit therefore error also depends on the incoming weight to neurons which is ultimate what need to be can change in neurons to stable learning in this example of injection training data loss function t minus y square y square t W and the loss function takes form of a parabolic cylinder with a base direction along WI 1 minus W2 since all set of let's simplify W1 W2 minimize the loss function in this case additional constraints are required to convert additional constraint can early be generated by setting a specific condition to the weight owned by addition training data, one common use algorithm to find set of weight that minimize the error gradient distance by Essentially, based descent direction calculate of loss function variance as giant sympathized weight, then the weight can be modified along with a slip-based descent attended method involve calculation derivation that plot function with respect to the weight of the network. This is normally done using back processing one output neurons. Describe the error function is ELTY, where the L is the loss of the output, Y target value, T is the target output for the training sample, with the actual output of the output neurons. For each neuron, J is output, OJ is defined as OJ network activation function. Phi is the non-linear differential, where the activation region RU is the known principal data point and historic usage. Activation function and logical function by default, which is the conventional derivation by comparison input and needs and neurons is weighted sum of the output. Okay, for previous neurons it is say the first layer after input layer. Okay, of input layer are simply input k. So input transfer function net input next activation function threshold activation diagram of artificial environment use and notation use here. Second order gradient using a Hessian matrix of second order derivation of error function even a brain's algorithm which covers the first order digit, especially when the topology of the cell is combined. It may be finding solution similar node counting for which might there might be node coverage hashing can be pointed by the Fisher information matrix losing function. The loss function is a function that map a value of the one or more valuable on to a real number initial respond on cost associated with those values. For back progression, the loss function calculate difference between neuron output is expect output after training. Example as propagate through the network assumption. The mathematical expression of the loss function must be fulfilled to condition in order for it to be possible used in back propagation. The first is that can be written as the average E1 by N EX for error function EX for N individual training example X the region of assumption that is backpropagation algorithm of error function for single training example which need to be to overall function. The second assumption is that can be written as the function of output from neurons a simple loss function. Select an error function when it means the difference between two output and the standard switch two dimensional neurons. One individual example event one gradient descent and back process is not guaranteed to finding global for error function, but only go global minimum also to be cross relatives on the error function and describe this is used by non-convex error function is in global function maximum precautions back propagation with repetition and the unexpressly chain rule with first writing down the gotten film which so such into neural network terminology back propagation error was introduced by Frank Grossman, but he did not however tried the in case only neurons was output of their attention level. Modern back propagation